Hi, everyone. I think we may have some technical problems on Georgia's side, so we apologize. You can't see. This show is going to be all about the eye. I hope we're going to get Georgia back in a second. Have we got? That's great. We've got you back. That's a good way to start. Okay. Hi, Georgia. Hi. Oops.
About that. It's a rainy day here in Ann Arbor. So apologies for this strange start, but welcome to the Humans and Wildlife Show. I believe it's episode 15. I'm Georgia Auteri, and this is my co-host, Dr. Christian Sase. Christian, what are we going to talk about today?
Yeah, today it's going to be really exciting. It's going to be all about the eye. That's something that has at least fascinated me for a long time. It's very difficult actually to photograph the eye, and it's so interesting. What do we see? How do the animals see? Do they see better than us, worse than us? That's what we're going to talk about. So, Georgia, what do you think? Is your
Yeah, I
reception?
think that it's a very exciting I think it's a super exciting topic, and I'm curious to hear what you have to tell us. I know that you were hoping to start with the eagle eye, an iconic eye of the animal world. Would you like to tell us a little bit about that?
Yeah, let's jump right in because that's probably one of the most that's probably the thing that we associate most when it comes to vision. We could talk about eagle eye, as you say, and there are many associations that we know of. Well, the eagle eye is 4 or 5 times, 8 times as good as the human being. It turns out that all these parallels are more or less wrong. And in order to explain that, let's go a little bit into what the eye is all about. So I'm going to jump right in now. Let's get there we go. There we go. That is, so let's start with the human being. How do we perceive color? Well, that's very interesting because, um, well, it is our eye is very much adapted to the sun and the way we see things because the sun has its maximum its maximum wavelength. So that's where you see most in the yellow and green. That's why we perceive the sun as yellow. And as it gets red, we don't see the sun so well. And as it gets blue, we have more difficulties in seeing too. And if you look at I'm just going to try and enlarge this a little bit. 1 second. I'm going to put that on full screen for a moment. There we go. So this is what we call Tri-Chromatic Vision. So these are our cones, and they are in red, green, and blue. And that comes as no surprise because those are the main colors. And with these main colors, we can basically form any color that we wish. And this is something that nature has beautifully done in our eye for many years, for many, I would say for millions and millions of years. It has adopted
many, many years, millions and millions of years, in fact.
millions and millions of years, right? But at nighttime, it gets very different because at nighttime, our vision is not that great. And it was only in 1825 when there was a Czech scientist who walked outside who was very perceptive, and he noticed that just as it gets dark and as the light comes in a little bit, he could see blue already, but yellow and red he would still perceive as black. And that's quite a good observation because what happens then at night is our rods kick in. It's more and more the what we call the scotopic as opposed to the photopic. And as the rods kick in, the sensitivity actually goes up, but our color vision goes basically into gray, right? So we see shades of gray. That's where the expression shades of gray come from. But we can distinguish blue better than any other color, which comes a little bit as a surprise. So that's our eye. So the question then, of course, is what happens in the animal kingdoms, especially with nocturnal animals or bats, Georgia, as you have studied them in detail. What happens with them? And I think that would be nice to explore that. Maybe we start with the eagle. So let's do that. So that's the human eye. And I'm going to look now and see where was the human. Yes, here is the bird's eye. Okay, let's have a look at the bird's eye. So the bird's eye is very interesting. First of all, we notice that's not um, trichromatic vision. They have tetrachromatic vision. Most birds have that, in fact. So they, in addition to red, green, and blue, they also have a very good perception in the ultraviolet, right, which they make good use of. In fact, the way birds see colors is very different to human beings. And I have this very nice comparison. Let me just try and find it. Just bring this up here. This is rather interesting. You see, here you have human vision and you have bird vision, right? So the way birds perceive color is very different. And in fact, a lot of these beautiful iridescent colors that we value so much are very differently perceived by birds than they are for human beings. So you can see that, and that is because they have this additional photoreceptor that is very sensitive in the ultraviolet, as you can see here. So we can't really, we appreciate a lot of these beautiful iridescent colors, but a lot of these things we can't really see. And surprisingly enough, hummingbirds have the best photoreceptors of all the birds. They can perceive apparently most of the colors. So that's really interesting. But then let's jump to the eagle. So what about the eagle? Why doesn't the eagle see all these beautiful colors? And the answer is nature. Nature finds practical solutions, really. So perceiving colors is very, very important if you want to appreciate your mate and the full beauty of that. Then, of course, we want to perceive all the colors. But maybe for an eagle, the idea of the eye is very different. So let's jump back into the right. Let me just get the center picture back up again, full, so you can see that now. You just yeah, there we go. So this is where it gets really interesting. So we have cones. I think Georgia disappeared for a moment. Hopefully she'll be back very soon. So we have cones and rods, right? So these cones are color sensitive. That's what we've seen. Now in birds, as I just mentioned, they have 4 different photoreceptors, right? Now it gets even more interesting because on these photoreceptors sit tiny microscopic lenses, and that's really fantastic. They are made of oil. These are very fine oil droplets, and these oil droplets act as microlenses, right? And these microlenses give them additional ability to really see a lot more light than we. But it gets even better than that. And then, gentleman ghost, I see your question, then I will get in there straight away. Let me give you another perspective of these oil droplets, because this is really fascinating. These oil droplets that birds have in front of their photoreceptors are filters, actually. They are very fine filters. We call them frequency filters. So this is absolutely crazy. So, for example, where they have their red sensor, they would have a special pigmentation that allows red light to penetrate and blue light to be absorbed. And that's what this diagram is showing you. On the left-hand side, you can see how a clear oil droplet would look like. So it means that any color of light penetrates equally well. But through the pigmentation or the coloring of the oil drop, the blue is absorbed. And then you can see the yellow, and then the red really filters out very well into the end. So you would ask yourself, well, why would you do that? Aren't you losing light? And the main reason for this is actually contrast. Sharpness and recognizing objects is all about contrast. And imagine an eagle now flying above water. You see these incredible reflections that are coming off the surface of the water from the sun and are really disturbing the view. For us, it would be almost impossible to catch a fish coming in at a very shallow angle. Well, this is where the eyes of the eagle, especially these droplets and these fine filters, help to increase the contrast. And also, you have to imagine, as the eagle goes underwater, you get refraction, right? There where the fish seems to be it actually isn't. It seems to be somewhere else. So there are a lot of decisions that an eagle has to make where color isn't that important. It's contrast, right? Contrast is sharpness. And that's what nature has solved in an absolutely beautiful way. I hope Georgia will be back. I know she's having a little bit of problems, so I'll just keep on talking right now. So that's the main thing. But there's one other thing. Okay, are you okay?
Yeah, so I joined from my phone, but I think
Okay.
you need to put my new image up because I have the computer in the background.
Your new image. Sorry, what meaning? Sorry, what? One
Yeah,
second.
do you see me? Like,
I'm going to wait. I'm going to put you on the full screen for a moment. Just hang on. There you are, Georgia. There you are.
sorry
So we see,
everybody.
yes, we see you. We see your teeth beautifully.
Hello. Oh wow, I'm back.
We're
Yeah,
having a
so
little.
I missed like all of the like physics lesson.
Yeah, we missed a little bit of. Hang on, let's bring this right back. It's okay. It's what an irony. We're talking about eyes today, and this is what it's all about. Is trying to see where Georgia is, right? And even the best eyes don't seem to help us today. There she is. Anyway, so that's very funny. So
Like a
sorry
little bit
about
of
that,
like
but.
Where's Waldo? Yeah.
But that sometimes makes things so interesting. Okay, one second. I'm going to just show one more image that is important, and then I will jump away from the eagle. So let me just show this one. One second. So there's one other thing so we're talking about contrast of the eye right now. That what gives an eagle very good very good sharpness, right? But there's one other thing. They have two fovea. So we have one fovea. That's where our lens and the light concentrates on the retina. There's an area that is very sensitive to light where the photoreceptors are, and that's called the fovea, right? Where the optic nerve goes. So then there is actually raptors, eagles have something else that's quite special. They have two fovea, so they have monocular vision, which means with one eye, and they can also look with both eyes. So their far vision, you can see this very often. An eagle will oh, I better put my head on there. Wait a second, so you can see what I'm doing. But what let me try again. Oops, now I don't know what happened there. Now the other birds came on board. I don't know why. Let me just remove them. Sorry about that. Okay, there we go. Now you should be able to. So if I lean like this downwards, you very often see when eagles try and see if there's any threat, another eagle in the sky, they will bend their heads completely down like this and look straight up. That's monocular vision. So that is 30 feet and beyond, 8 meters and beyond. They will use monocular vision. And then as the object gets closer, and I've often done that. So an eagle, when you're far away, will look at you on the side. You think that eagle's not looking at you. In the meantime, because that's the side vision that you can see in the diagram, that's a monocular vision, is looking straight at you. And as you come closer than 30 feet, approximately 8 meters or so, and you come closer and closer, you'll find that the eagle suddenly turns to you and is looking straight at you, and then it's using its binocular vision. So they have these incredible abilities which we don't have, plus they have approximately a 330-degree panoramic vision, which is unbelievable. They have certain blind spots, but they can almost see right around like many other birds can too. Okay, so that's the that is the excursion on eagles. We are a little bit jerky today, and I don't understand why. So sorry about that. Maybe, maybe the stream is a little bit overloaded with all the pictures that we're trying to show. Okay, so Georgia, are you
We
still
also
okay?
have a question from David Howden. Sorry, we have a question from David Howden. I wonder how birds would perceive the images on screens like this.
Let's just get you back on here, Georgia. We want to see you. There you are. Okay. Yeah, that's a good question. So um, I don't, there are probably two answers to that. The one is that our human eye is very well adapted to sort of medium focus, medium and far focus, right? So in most cases, we would probably see things sharper than birds, except for eagles and some raptors. But from a color perspective, um, you're talking about the screen. So the screen, of course, has been optimized for the human eye, right? So there's not a lot of ultraviolet in there. So probably the I mean, I'm guessing now, but my guess would be that because the ultraviolet is very low there, it probably would look rather similar. It just gets very interesting when you go out into nature, where there's ultraviolet light and many dark blue lights, or many much more red lights that we cannot perceive, where it gets very different.
We have another interesting question from James Bourne. I'm worried that eagles will eat bright red poisonous frogs. Can this contrast vision perceive dangers like that? So there's like a few interesting things going on there. One is that the reason things are noticeable, like bright colors, is usually because they're advertising to things that might eat them that they're poisonous. So those bright red, bright colored animals have usually evolved to be that way for the very purpose of what way can we best convey to things that might want to eat us that we are actually not good to eat. Um, so I wouldn't worry, I guess, too much about the eagles in that sense. Um, yeah, I don't
Yeah,
know,
I
Christian.
think you nailed it, Georgia. That's exactly right, right? Nature, they put out these warning signs not because they're trying to hide the poison. They're trying to make it very obvious. You're completely correct. Yeah, I think that's right.
Yeah, and you can
So
get weird things like with climate change. I won't digress too much, but yeah, like if you suddenly have eagles that see bright red frogs and they weren't used to seeing them before, um, then you might get problems. And with like climate change, those kinds of mismatches can happen. But Christian wants to tell us more about eyes.
well, it's just, I mean, this is such an interesting subject. I can tell you, I was reading till the last moment about this, and I have to be very honest. I don't know much about this subject, right? I just read a lot, and I will tell you what I know, but I know dangerously little. I just have to be very clear about that. Okay, it's just a fascinating subject, and there's so much to learn. So let's jump into some. Let me just look here on my cheat sheet, because there's so yeah. Let's go to the owl very quickly. Okay, the gray horned owl and so on is very well known for its night vision, and they actually let me just see. So of course they are specialized for that, and they have what we call the Torpedo Lucidum behind the retina, and that's what you see in dogs and cats. That was shines so much, right? Many mammals, many animals have that, and we don't have it, unfortunately. So if I hold a flash into your into your eyes, you get this horrible red, this red that we are trying to get rid of. That's not the tapetum lucidum. That is behind the retina, just the pigmentation that is reflecting. Whilst if you would flash at a cat or a dog or any most of these nocturnal animals, you will see this reflective this reflective layer, and that's very nice because a lot of sensors and cameras are built in the same way. We call this backlit sensors, right? So light is coming in, it's very clever, and that's what gets lost, gets reflected right back into the eye. I don't know why they didn't design our eyes like that, but I would have loved to have much better night vision. So that explains why owls are much better at night vision. They have, of course, many more photoreceptors than we have, and they also apparently have the ability to see to see in the very far red. It's not the infrared, but the far red, where we can't see anything. Think about these night vision cameras. For example, these cameras that we these lights that we have on the web, where at night you can see everything in black and white. The eagle, similar to us, doesn't seem to doesn't seem to see that spectrum of light in the red, but it seems to be that gray-horned owls can see it, because there seems to be evidence that as soon as you put a Nest camera there with night vision on there, there seems to be an increase of attacks of owls on the nest. That's especially bad for juveniles. So there seems to be evidence that owls can actually see that.
Yeah, and as I understand it, perhaps I'm not correct in this, but as I understand it, that film, that glowy film you're talking about, the Torpedo Lucidum, there's a cost to that, in that it's basically a layer that's like bouncing light around inside the eye more to maximize your nighttime vision. But all that extra like bouncing around has the cost of blurring your vision a little bit, whether it's nighttime or not. So like that's why some animals see things a little bit blurrier. Like your cat doesn't see things as quite as in focus as we do.
Yeah, that's right. But maybe that's not important for them. But it's like you correctly say, it's more the sensitivity. I mean, the ultimate, of course, when it comes to night vision, is the rattlesnake. I mean, let me just put a picture on there. I found this absolutely fascinating. Look at the rattlesnake. So the rattlesnake, between its eyes and its nostrils, it has an extra sensor, and these are thermal sensors, right? These are very, very fine nerves with which they can actually resolve. It's unbelievable. They can really resolve rats and other things that they are trying to prey on with incredible, often better than our human eye. That's unbelievable. I was completely surprised to see that. And that gives the snake, for example, enormous abilities. For example, if it would inject its venom into its prey and its prey would be running, the snake wouldn't be worried because it has these heat sensors. And you know, even if it lost the heat sensors, it's got these incredible smell sensors that are so sensitive that it'll pick up, you know, small bits of blood. So it has the heat sensor and then also the incredible sense of smell. So it's incredible to see what abilities animals have, right? So, and that you could call also a type of eye.
Yeah, they're coupling their vision with their other senses basically. And I think humans can do this too. We maybe don't pay attention when we're doing it necessarily. We take it a little bit for granted. But and I guess like another classic example of pairing senses in order to cope with like nighttime vision deficiencies would be the bat, correct, Christian?
Sorry, I was just looking at David Howden's comment. I beg your pardon. I wasn't sorry.
Yeah, he's saying he's pretty sure that foxes can see the red
Yes.
light, I believe. They come to look at the trail cams, he said. And so,
Mhm.
yeah, I think also those trail cams, well, yeah, some animals can see the lights and the infrared
Yes.
and also sometimes they emit like a little bit of noise or something. Or even if it's new, like if you put up a trail cam that's somewhere, the animals see the camera and they know like that wasn't there before, some of them. And then they come and investigate. Um,
Yeah.
yeah.
What is very interesting, for example, there's an animal that has very good night vision, and it's a gecko. Actually, I was surprised to read that. I didn't know that. And the gecko, the vision of the gecko is very much adapted to starlight. In fact, that's incredible, isn't it? So that must have again been millions and millions of years of adaptation. So we basically have three different types of lights. The one is sunlight, the other one is the moonlight at night. But as soon as the light of the moon gets less than about half of a moon, that doesn't play a big role anymore. And then comes starlight, right? We used to have these I mean, I'm forgetting about light pollution now and city light and all that. That our animals we're not made for that. But the gecko has incredible sensitivity in the blue and also in the red, and it appears so that starlight has some peaks in the red because of the hydrogen emissions and so on, which which surprisingly geckos can pick up. It's just insane. So yeah,
Yeah, so we have a rattlesnake here, and I thought I added some bat photos. Oh yes, here they are.
you want to talk a bit about
So
bats?
let's put these up. Oh
Yeah,
yeah, we're
that's
switching. We're going through all the nighttime animals, I guess. as how we ended up doing this. So the bats, oh, thanks for taking off. So we have two very different types of bats here, and I'm curious if people can guess why the bat on the top has like pretty big eyes, right? And the one on the bottom has much smaller eyes. And I'm curious to see if we can get some guesses from the audience as to why that might be. Um, Trying to think of clues that I could give. You think about why one might need better vision versus not. We talked a little bit about coupling different senses with the rattlesnake. So the rattlesnake used its sight and then also its like sense of smell to have this like amazing nighttime hunting ability. Oh, no guesses so far. The bats on the top are part of a group of bats that are commonly called dog-faced bats because they have these like kind of big puppy dog eyes. They look very cute. Mark Kachik has a comment: big ears versus small ears too. Yes, this is a real clue. Yeah. James Bourne says he wasn't expecting a quiz. Anxiety. Oh,
Anxiety.
sorry, I didn't mean to induce anxiety.
And
I'm
Cherie,
teaching this, so I'm in
Cherie
full on teaching
suggesting
mode.
sonar,
Sheree,
right? Sonar.
yep,
Yeah.
Sheree has the answer: sonar or echolocation. So the bat on the top actually doesn't use echolocation. It relies primarily on its vision, and in fact, it has probably better nighttime vision than humans do. This is completely in contrast to the idea blind as a bat, that bats don't have good vision. Many species of bats, their vision is just as good as humans, if not more so at night, which makes sense. It's hard to see at night. Um, but yeah, the bat on the top doesn't use echolocation and it eats fruit. Fruit are relatively easy to find at night. Fruit don't put up much of a chase. They don't doesn't move around, but fruits are also colorful, right? And so one of the best ways to find fruit at night is to have really good nighttime vision and have these bigger eyes. The bat on the bottom actually eats insects, and its primary mode of hunting is echolocation, sonar. And so the insects are very small and moving around, so vision isn't as useful for finding them. So bats like the species on the bottom, these insect-eating bats, have this sense of sonar that they've developed to help them at night. So they're not relying on their eyes as much, and they have pretty small eyes. They can see about as well as a human at night. But yeah, they're primarily using this other sense to find their prey, and they can hunt. If you like put a piece of tape over their eyes, they can still hunt. But if you tape their ears down, then they can't hunt. So that's why it's pretty cool how you can see like these two different types of bats, of big versus small eyes, based on how much they're using them, basically.
Do bats blink? Do all
So,
mammals blink? That's an interesting one. I don't know.
oh boy, we need some kind of award for a really good question that I really don't know the answer to, and I wish I did. Um, I mean, so certainly I would guess that dolphins and other mammals that live in the water probably don't blink. At least they don't, because I think that they have like another layer over their eye or something that protects it from the water, sort of like a clear layer. But I'm not sure. Bats will certainly close their eyes. Like if I'm shining my like headlamp or my flashlight in their face, sometimes they're like, oh god, like they kind of like close their eyes like it's too bright for them. But yeah, I don't know if the bats blink. Yeah, closing their eyes, but blinking. I think of a blink as like a sort of periodic thing that you have to do in order to keep your
Hmm.
eyes moist, and that's why I don't think of mammals underwater as needing to blink. I'm not sure. Christian, take us away from bats, and I'm gonna start
Okay, I'll take
Googling
you away
about
from that. Let's
blinking
go.
mammals.
Let's
I
do
have to
something.
know the answer right
That's okay. That's okay. As I was saying, this is such a broad topic, and I'm grateful for all the questions because honestly, it's just it's so deep it never ends. And we come to some completely different animal now, a goat. And why would I put a goat here, the domestic goat here? Well, think about the way the goat actually feeds or grazes, right? it has to put its head down, and the moment it puts its head down, it's actually in big danger, right? So how does nature solve this? It's fascinating. So a goat actually has a horizontal and rectangular pupil, very different to ours. Ours is round. It has a horizontal, so it's a rectangular one. And what is fascinating, only a few years ago, um, a, 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 a scientist who was studying goats noticed something incredible because he was wondering, the moment they put their heads down, wouldn't the angle of that, of their pupil change so that they wouldn't be able to perceive things properly? Because the ultimate goal for a goat is to see everything panoramic. So they don't have very good vision, but they have excellent panoramic vision. That's what they need. But what happens if they put their head down? You can imagine that the angle changes. And he actually videoed this in detail. Nobody had ever seen this, that the eyes actually roll to always stay horizontal, right? So they always have perfect panoramic vision. I find that absolutely fascinating. So, yeah. And then, of course, I mean, I don't have, let's just see, Georgia, we have so many interesting animals here. Let me
Yeah,
just,
let me bring up the goat a little bit bigger real quick so
oh
people
yeah,
can maybe see it.
can maybe see the
Or
eyes. Can you, yes, that's good. Can you see
yeah,
the eyes there? You see that they're
yeah.
always horizontal. So imagine the goat just bending down its head and they remain. So the eyeball actually rolls so they stay perfectly horizontal in order to achieve that. It's incredible. Ah, Gentleman Ghost says, I'm
Yeah.
picturing a peregrine
Two
falcon
things about
flying at 200 miles per hour. Yes, well, let's talk about the peregrine falcon. That is a great topic. Thank you very much. As I don't know, Gentleman Ghost, if you saw my script or our script here. Oh, sorry. Now I put it out of the way. I'm sorry. And put it back again. Maybe he read our script today. But the peregrine falcon is fascinating, absolutely fascinating. So, how does a peregrine falcon actually dive and keep its incredible focus on its prey? And you would think, well, that's easy. It's like someone who's diving would be straight down, right? Well, that's not the fastest way. You won't believe it. It's what we call a logarithmic spiral, just as you see it in the diagram. So it actually starts in a big spiral and gets smaller and smaller, and it turns at incredible speed. So why does it do this? Well, there are two reasons for that. For one, it turns out that the shape of the peregrine falcon is much better, that the drag is lower as it spirals down. So even though the path is longer, it moves faster. The second is the more important one, and that is that it is able, it is looking at its prey with one eye as it spirals down, and by spiraling, it will constantly be able to see a three-dimensional picture of it, right? Any movement or so, and correct for it. If you dive straight for it, you're using this binocular vision. It's very different. So the monocular vision is key here, and also keeping focus. And by turning, it's getting the dimensions of its prey. So absolutely fantastic solution of nature. Thank you, Gentleman Ghost, for bringing that one up. So that's the 200 miles per hour one, yes.
Yeah,
I
and
don't know what the
I don't know if we can put the two next to each other real quick, but that's often a difference in predators versus prey animals, is animals that are eating other animals like peregrine falcons. Like humans, we have our eyes kind of like we can focus on things really well, whereas like the goats, they have their eyes really pretty far out to the side in terms of where their whole eyeball is located. That way they can see like all around, see if danger is coming. Versus, I mean, birds are a little bit of a weird example because like they have their eyes sort of far apart as well, but they often like, yeah, like you're saying, Christian, are like using one of them to focus on something.
So
And so,
let's look
yeah,
at
how your actual physical position of your eyes, yeah,
that's
has a
correct.
lot
So
to do with what you're
let's
seeing.
bring up the world champion in big eyes, right? Who's got the biggest eyes relative to the head size, right? And that's the Tarsier. I think that's how you pronounce it, Tarsier. I can never pronounce this word, but I think that's probably how it's pronounced. And so it's got huge eyes. It's got incredible dense photoreceptors. It's a nocturnal animal, and it's got also this tapetum lucidum very well developed. So it may like Georgia says, not see things very sharp, but it has incredible perception of what goes around, what is going around it at night, things that we could not even imagine. Density of their photoreceptors are 2 to 3 times as much as we have, and so the vision, especially because of their big pupils, almost like a telescope, must be absolutely incredible. And then maybe just, I don't have a picture of that, but there's another fascinating animal, and that lives, the Nordic animal is the reindeer, of course, right? Imagine these long winters that you would have in Finland, right? These dark winters, or where you would just have brief twilight, and you have these long summers, right? So the reindeer has photoreceptors that are very much adapted to blue light, right? So it's more this night color and the reflection of that it gets through on, and also its tapetum is very active, and it changes colors in winter as opposed to summer. And it's reindeers are also known to react to UV light very well. So again, their photoreceptors are much more pronounced in the blue. So incredible, isn't it, what nature has done? I'm just telling you what I know. It's just amazing, isn't it?
Yeah, and Franklin brings up bugs up a good point, haha. That, we were talking about the eye size, and like insects, of course, they have very big eyes compared to their bodies sometimes, like dragonflies, or compared to their head. But of the vertebrate, like vertebrate animals with a spine, the Tazier, did you say it was? Yeah, has really big eyes.
And think of talking about, well, reptiles. Of course, you have to mention the chameleon, right? I mean, we can't. The chameleon is the most fascinating animal ever, right? Because they can move their eyes independently, which is incredible. So they have incredible ability to focus on their prey, because I mean they have to be very fast and so on. I don't know if you want to add anything to that, Georgia, but that's just an observation.
Yeah, I mean, I've never really thought about what's the limiting factor on eye size. Probably, humans, mammals, a lot of mammals have pretty big brains, especially humans, and I wonder if that like limits eye size in some way. I'm not sure. I'm totally just guessing here, but
No, that's okay.
yeah.
But anyway, so for a chameleon,
I
of
just
course, they
took a
can.
moment,
Yeah,
I guess, here.
sorry.
Oh, I was just gonna say, like, thank you everybody for the awards, because we've gotten several awards,
So
and we
many
just
awards.
got one
Thank you
from
so
Chameleon.
much. That's really appreciated. Thank you. So yeah, chameleons can also switch from monocular to binocular vision. Of course, UV light sensitive is incredible. So they must be able to see with it. I mean, if you look at the accuracy that they need, when they go towards their prey, you could just imagine. So the single eyes can rotate and be completely independent of each other. I mean, it looks a bit like a Dracula film, but it's just amazing what nature has invented. It's quite incredible. But then there's one special thing that we haven't mentioned, or maybe there are many things, Georgia, that we haven't mentioned. I have to just get the European robin out here. Where is it? So we don't forget it. Let me see. I'm not sure. Did I even put it here? Well, if it's not there, it doesn't
The
matter.
European,
Yeah, that's just the robin. Why
I
would I
see some
mention
pictures
robin?
of eggs in the cute.
Um, it's okay. Let me just. Oh yeah, here's a picture. Wait a second. It's not a picture. It's a schematic. This comes from Nature, the famous Nature magazine. Again, these are all very recent discoveries, right? So it's still a big question how birds can be sensitive to magnetic fields. It's actually not understood. It's something I've always asked myself. How can they possibly know where north and south is? And they seem to know it. And there seems to be a certain protein. Don't ask me which protein it is. It's discussed in Nature, that is responsible. It seems to be responsible for magnetic sensitivity, which is quite incredible. So we have to mention that. Because that's also a type of vision. You could see magnetic vision is a type of vision. So the same as infrared vision, where the snake has. So thermal vision. So that's still puzzling, how birds can follow magnetic fields. And here comes David, says, another random eyesight fact, tiger beetles run so fast they could go by. Are you joking? Really? I had no idea.
I know. This, I just want to say we've had the most amazing audience comments on this episode. I feel like I cannot believe this fact. I love it. Thank you so much, David Howden, for sharing that. And for those of you who don't know, David Howden also live streams regularly about insects. He talks about insects in the UK, a lot of moths. So definitely follow him as well if you're interested in hearing, I guess, more about facts like this. I'm
That's
curious if it's
incredible.
a temporary blindness or permanent blindness.
Yeah, let's jump to the red dragonfly. That's an interesting one. So here we are. So that is again, the red dragonfly is beautiful with its coloring, and as you know, a lot of insects have compound eyes and facets. I hope I pronounce this. Georgia, help me, please. Omatidia, is that right? Omatidia, is that how it's pronounced? Omatidia. Well, anyway,
Yeah, that
yeah,
sounds.
yeah, that's sort of lenses in the eye. That's sort of special lenses that directs the light through the. I mean, their compound vision gives them incredible. It doesn't give them sharpness, but my understanding of insects is that their compound vision is incredible sensitive to any movement. Right. That's the key thing for the fly and for the dragonfly and so on. I think what's interesting about the dragonfly is it also has a wide range. Yes, it has 20. It well, it has very high sensitivity to wavelengths. So it's not only the compound structure of the eye, but it's also very sensitive to different colors that make it extraordinary. Oops, let me just switch this off 1 second. Yeah, 1 second. Let me just switch this off. Okay, there we go. Yeah, and then finally, wait a minute. Have I lost you? Am I still there? 1 second.
I still see you.
Oh yeah. Okay. Sorry, I must have lost you for a second. Unfortunately, we don't have the what is it? The gosh, run out of it. What is the mantis shrimp? Right? Is that the one?
Oh, the mantis shrimp. Yeah,
Yeah.
the aquatic invertebrate. It's the shrimp that lives in the ocean in these little sort of burrows underground, I believe, and is quite vicious. In addition to having amazing eyesight. I think, yeah, tell us about it, Kristen. What's so amazing about the
Yeah,
mantis shrimp's eyes?
I mean, there's so many things that are just being discovered. We actually know very little about animals. And we know so much about the human eye. You have all these journals, but when it comes to the animals, it's so open everything. And a lot of this is only been discovered here from 2010 to 2020. I could not believe it. Georgia, you're probably more used to this, but for me, this was an absolute revelation and shock at the same time. But when it comes to the um, to the mantis shrimp, what is interesting, it probably has 12 to 16 different photoreceptors. So think about it again. We have three. Birds typically have four. Then there's some insects that have 5 to 6, and then comes the mantis shrimp with 12 to 16. And it has this incredible hammer with which it knocks out its prey, which is also so
Yes,
fascinating.
it uses its claws. As, yeah, it uses its claws as a hammer. So, like, if you think of like a lobster claw or something, the mantis shrimp, when it wants to kill its prey, it's waiting in its little burrow or den or whatever, or maybe above the den, and then it has its claw and it just knocks its prey out, punches it underwater. um and it's kind of an incredible thing because it's not easy to build up a lot of speed underwater, correct? And yet the mantis shrimp is able to do so. I think it's like, oh, there's very strange things happening. Like I think like technically like a bubble somehow forms in front of its claw because it's going so fast, and like that's what makes the impact. I don't quite remember, but yeah, it has an incredible basically like underwater hammer punch skills and amazing vision. So it's quite formidable as an underwater predator, I believe.
Yeah, what my understanding of the mantis shrimp is because it's underwater, it's something, first of all, it's compared to a 22 caliber gun. Not that that means much to me, but anyway, it sort of has a force somewhere around 200 pounds. Just, I mean, knocked out. It's just incredible. But second of all, Georgia mentioned exactly the key point, what happens underwater. So just imagine you have this incredibly fast movement underwater, and you have to see that with a high-speed camera, a very high-speed camera, actually. And as it is moving and hitting its target, behind it, it is creating almost an underpressure. And that underpressure of water is so much under pressure that it starts to boil. You won't believe it. For microseconds, this starts to boil because it's like causing a vacuum somewhere. As soon as you cause a vacuum, anything will evaporate, and that causes it to boil. So that is another thing, and that is that this incredible explosion within water and the change of phases then creates another second shock wave. It's incredible. That gives another pound in very short succession. So it's an ingenious invention. Yeah. And maybe finally, Georgia, the
Yeah,
other.
Christian, I am sorry, I just am adding a photo of the mantis shrimp. I just
Oh,
pulled it
please do,
offline.
please do.
If you want to add it, just so people can see this amazing animal before we switch
Yes.
topics. They look insane. Um,
Ah, there it is. Yes, thank you. It's beautiful. It's absolutely beautiful. The
yeah,
colors
they are
are.
quite gorgeous. You can tell, you can get a hint from looking at them that their eyes are just insane. It's like their eye, they look like an alien or something. Um,
Yeah, and finally, maybe just one more, just mentioning the cheetah, the beautiful cheetah. You have maybe noticed that the cheetah sort of has these black tears under its eyes, and that also has a purpose, by the way. That has a purpose to diminish any reflections that you have, right? Because it's black, so it'll be able to focus on its prey much better. So everything there, has a purpose around the eye, inside the eye. It's just absolutely incredible, what nature has invented. Ah, yes, yes. Here comes Scott. Thank you for mentioning that. That was Diana Cowan. She's the physics girl. That's where I remember it from. That's where I remember it from. So he's just saying who mentioned this. This is exactly right. So I'm just going to put this on the screen 1 second. Thank you, Scott, for mentioning that. That's where I recall seeing this. That's correct. That's that's an excellent video. I think the slow motion guys also made a video on it, and several others. So, and I would love to do one too, but I have to somehow get the possibility of doing that. It's quite incredible. Yeah, that's it. You mentioned all the big names there.
yeah,
That's
there's like
good.
very interesting things about mantis shrimp from several perspectives. And we have a comment from James Bourne, another one, do tardigrades have eyes? And then he's just like, oh, kidding. Um, and tardigrades, for those of you who don't know, they're also called water bears. They're tiny, tiny little guys that are only about half a millimeter long. They're known for being able to like survive the vacuum of space, but they have simple photoreceptors, maybe not what we would call an eye, but they are able to sense light. So I'm not sure. Tardigrades are cool animals too. They're actually just in the news because a new species of tardigrade was discovered in some amber. So like a fossilized tardigrade from like or preserved tardigrade from long long ago was found like Jurassic Park style in some amber, and so I'm not sure if that's what brings up the topic of tardigrades or not, but an example of the early eye.
Yeah, That's a good point. Anyway, I did want to show maybe one final slide that is beautiful, gives you all the comparisons, and I will give you the literature source here. One second, let's just remove the, where the mantis, 1 second. So that is, I'm just going to put this big on the screen, Georgia, because that's a bit difficult to see. 1 second. So this is a nice summary of, let me just go to 1 second. Let me just go to the article very quickly so I can have it on the big screen. Otherwise, it's difficult for me to explain this. Yes. So this is a summary where you see light, how much light you have, light intensity on the horizontal axis. So it gets really dark to the left, right, and it gets very light to the right. And right at the bottom is the human being, right, with our trichromatic vision. So you can see the photopic, then the mesopic, that's sort of in between, and then scotopic is at night. You know, how much we are able to see, and you can see that's the transition from color to monochromatic. And it's very interesting if you go through these different animals, you'll see that honeybee, for example, has much better abilities in the ultraviolet. And then there's the hawk moth that can see colors at night, which is incredible. And a lot of question marks of things that we don't know. There's such a thing as the nocturnal carpenter bee, also, that has an incredible sensitivity right from the very bright light to the to very dark lights. And then the Todd food, or what Todd food or Matrix, I'm not quite sure what that is. Wait a minute. Yeah, the frog phototaxis, that means, I think that means, Georgia, if a frog moves towards light, I think that's what phototaxis means, I presume. But they're also very sensitive towards light. They've experimented with blue and green light, and you can see the frog seems to be the most sensitive and goes into incredible darkness where the frog can still distinguish different colors. So that's just a nice summary. I'm going to give you the, let me just find the article here. I just downloaded that. 1 second. It's called, yeah, I'm just going to put the title in, and then you can Google this. I can't find the link at the moment, but I'm going to just put it here because that's where we got a lot of our information from. There you go. So,
yeah, yeah, phototaxis, Christian, it usually has to do with like something with movement in relation to light. So how much you move or something, whether you move towards or away from light sometimes,
right.
or sometimes just whether or not the brightness like elicits movement in you, depending on what you're
Yes,
talking about.
yes. 1 second, I'm just going to try and find the proper link of this, and then they can find the PDF because that is very nice. Let me just see. And these are all very recent articles. You won't believe it. It's quite incredible. Yeah, I think here, and you might have to then look for the PDF file because sometimes you download the PDF file from somewhere else. Here it is. Yeah. And absolutely fascinating. I'm going to give you another link that is really amazing, where a lot of this information came from. And there's another link here. That is 26 animals at night with, and comparing their vision. So I hope that gives you some background of what Georgia and I have been talking about. Okay.
Yeah, and we have another good comment from James Bourne. I'd love to see a video that shows how each animal type would see as compared to humans. A good 30-hour video, he says, yeah. And like I've seen some of this before where people have tried to sort of show like what a dragonfly's eyesight would look like or something like that. And the truth is like to some degree we don't
Oh,
know.
sorry.
We're guessing a little bit when we try to filter and say like, oh, this is what like a cat would see or something. But you can find for like cats and dogs and for insects especially, some people have tried to come up with these videos, yeah.
But it's very difficult to do that, right? It sounds easy, but it's very difficult because what you're mimicking is two things. You have to first mimic the whole eye with the lenses, which is difficult enough, and then you have to find out the spectral response of the photoreceptors and understand how that would be. That is a huge thing. So it's a tall order, gentlemen ghost.
Yeah. And I mean, yeah, ultimately we're seeing it through human eyes still. We can
Hmm.
only see things through human vision. And so we can't really know what it's like to see more colors than the scope that we're able to see. And I mean, you see these, these images like, oh, this is what a flower looks like to a bee if you can see UV light or whatever. But we're still, it's still a quite the translation where I think there must be something lost in between because we don't know what ultraviolet, we don't know what it looks like. Um, yeah.
Yes, by the way, Janie was asking, can you post this chart, Christian, on your Facebook page? I will definitely do that, of course. Love to give any education onwards. I will do that. I will post it there. Yes, I will do that. Sure. Good. Well, Georgia, I think that's I'm at the end of my wisdom now. Do you want to add anything?
Yeah, I don't really have anything to add on the topic of eyes. I think that, we I learned a lot. I have a lot of good questions in mind. I'm still hung up on this animals blinking um comment. I'll be doing a lot of episodes or a lot of research on that. It could be like a whole nother episode. Um but yeah, I appreciate all of the wisdom from the audience as well and all of your questions and insights.
Yes. Thank you. I
Any oh,
can.
Cherie has a comment. Any info on the glasses made for people who are colorblind? That's actually just what I was thinking when I was talking about, oh, we don't really know what it's like to see these different colors. If you haven't looked up like the videos of they have glasses that can help like people who are colorblind see like distinction between different colors, or I'm not sure. But yeah, there's amazing videos on YouTube of like people putting on those glasses for the first time and like seeing the world in a whole new way. I can't imagine what that would be like. Yeah.
Yeah, and is it true that dogs see in black and white? I believe that's correct. I believe that's correct. Yes. But again, I'll ask.
Yeah.
You
So
know what? I'm going to ask my Jack Russell after the show. Okay, so we'll see. I have no idea. Okay, well, thank you, everyone.
yeah,
Thank you
like when
so
we talk
much.
about like videos for animals, like yeah, like how other animals see the world. I think it's relatively easy to make a video if like an animal sees like quote unquote worse than we do. Then it's kind of easy to make a video like, ah, yeah, just put it in black and white and make it a little bit blurry or something. But yeah, especially for animals that can see in ways that we can't, it's yeah, quite a bit more difficult. But yeah, thank you for the award, Frankman, and thank you everyone else for joining us.
Yeah, thanks for all the comments and all the kind of words. We appreciate it, and yeah, we do put some effort into it. We hope this was helpful, at least to scratch the surface of an area that is incredibly interesting. And if you like that, we could go through the other senses too, maybe the sense of smell, touch, and many other things. Georgia, what do you think? Because comparing that, maybe that's something.
I think that would be a pretty cool topic. Um, yeah, I'm trying to think of like themes or like particular times of year that would be good for all of those. But yeah, I think we could go through. Certainly, we have a lot of different like with the bats and hearing and sense of smell. It's kind of famous that humans don't use their sense of smell as much as other animals, or we tend not to. So I think it would be pretty interesting. Yeah, let us know what sense you want to hear about next.
Yes, please leave comments, and we do read them. So thank you very much, everyone, and we'll see you, yeah, probably next week, right? Oh, Georgia, you wanted to make an announcement about bats, so we don't forget. You said something.
Oh, yes. Yeah, so just as a note, October is the month of bats. It's really, in many places it's like the month for Halloween, and Halloween is associated with bats. So I'm going to be doing some extra broadcasts from my HAPS channel um, about bats, probably an extra one each week focused on like different bat themes. And so I think it'll probably be some weekend day, but I'm not sure yet. Saturday is always nice because then it can be batter day, but I haven't decided on a time yet. But definitely sometime later this week will be the first one. So make sure to follow or subscribe to me if you don't already. And if you want to hear more about bats during October, during our Halloween month, at least in many countries. Okay,
Very
bye
exciting.
everybody. Thank you so much for joining.
Okay, thanks everyone. Thanks for joining, and have